Hi guys, today we'll be looking at a question on work, energy and power. A constant force F is applied at an angle of 30 degrees to the horizontal on a crate of mass 6 kg that is initially at rest, as shown in the diagram below. A constant frictional force of 10 newtons acts on the crate as it moves from rest at point A along a horizontal surface to point B. The distance between point A and point B is 1.5 meters. The speed of the crate at point B is 2 meters per second. Question 5.1. Define the term work done by a force. So this is yet again another definition, so if you just learn it, it's easy 2 marks. The definition is that the work done on an object by a constant force F is F times delta x times cos theta, where F is the magnitude of the force, delta x is the magnitude of the displacement, and theta is the angle between the force and the displacement. Question 5.2. Draw a labeled free body diagram showing all the forces acting on the crate as it moves. So we can say that this is our crate. As the crate moves on a surface, it obviously has its weight downwards, and opposing that, it has a normal force upwards, which is the force of the surface acting on the object. We then have friction, as it says in the question, in the opposite direction of which the object is moving. And at an angle of 30 degrees to the horizontal, we have the force applied. Question 5.3. Using energy principles only, calculate the magnitude of force F. So, force F we can determine by calculating the work done on the system by the non-conservative force, as this would be WNC is equal to the change in kinetic energy plus the change in potential energy. We then know that the work done by the two non-conservative forces is the work done by the force applied plus the work done by the friction force. And this is equal to a half mVF squared minus VI squared plus mg HF minus HI. We then want to calculate the force. So the work done by the force applied is F, 1.5 being the distance, as said in the question, and cos theta being an angle of 30 degrees, so cos 30. The work done by the frictional force is 10 newtons, as they tell us that's what the force is, also a distance of 1.5, and it is working in the opposite direction of motion, therefore cos 180. This is all equal to a half, mass of the object being 6, the final velocity, which is 2, and the initial velocity, which is 0 as the object is at rest. And there's no change in potential energy as the object does not go up a slope, so there's no height difference. So final height and initial height are both 0. So this term cancels out. And if we plug all of this into the calculator and solve for F, we should get F to be equal to 20,78 newtons. Since it says the magnitude only, we don't need to calculate a direction. Question 5.4. A 2 kg object is now placed in the crate. What effect will this have on the work done by the same force F when the crate is moved again from point A to point B? Write only increase, decrease, or remain the same. If a 2 kg object is placed in the crate, the force of the object would still the work done by the force would still be the same, as even though the force would need to go up due to the friction going up, they would have the same proportion, as the end velocity would also decrease due to a heavier mass. Therefore, the work done by the force would remain the same. And that's all for this video. Thank you.